Okay, this concept of detections versus limits is something that seems to give a lot of people a lot of trouble, and I'm not entirely sure why. If I understood better why it was giving people trouble, I would teach it better. So please help me understand how to teach this better. So a detection is a source that is seen in the image. You can, by seen, I mean the computer sees it or your eye sees it, but when the computer sees it, it covers a wider range of brightnesses than it does when you're talking about just the computer seeing it. You can always adjust the stretch or the color table of the images to either convince yourself that the computer is right or convince yourself that the computer is wrong, but the computer is more sensitive than your eye in this context. We have data for any of the NITAR projects that we do over a huge range of wavelengths, ranging from blue out past, easily 160 microns. So if we can see the source in more than one band in the images, but not in other bands, we know for sure the source is there because we can see it in some of the bands. But if we can't see it in other bands, it just means that it's too faint at that wavelength to appear in those images where it's missing. Okay, try to think about that. The source is really there. It's just too faint to show up. So what we do is we say, okay, we need to look at the images where it's missing, assess the noise level at the location. We know for a fact that the source is really there. When we look at the noise level in the image where it's missing at that location, then we know that the source must be fainter than that, otherwise we'd see it. That's a limit. Okay? So here's an example. This is from a tool called Find Your Chart, with which you're going to become very familiar. But the source is really and truly there. That's 2 mass J, H, and K. So the source really and truly is there. It's circular, it's bright, it's very clearly there. The source is also very clearly there and bright and circular at WISE1 and WISE2. It's not ambiguous. It is definitely there. It's clearly there. But is it there at WISE3 and 4? I doubt it. I don't really see anything there at WISE3 and 4. Now, there is some bright source of some sort up to the north there. It's possible that if I played with the stretch, I might be able to convince myself that there might be something there at WISE3, but I am super skeptical that there's anything there at WISE4. So, without even looking at the catalog yet, I'm already going in skeptical that it's really detected at WISE3 and WISE4. I'm not skeptical that the source exists. The source clearly exists. But I don't think it's detected at WISE3 and WISE4. So then I can look at the catalog provided for us by the WISE team and look and see, okay, is there a measurement at WISE1 and WISE2? Almost certainly. Is there a measurement at WISE3 and WISE4? I need to look at what the computer is telling me. Is the computer telling me there's a detection? In which case I go, I don't think so. I'd make the SED and see if those points are consistent with the rest or ludicrous given the rest of the SED. If it's consistent with the rest, fine, I'll believe the computer. If it's ludicrous given the rest of the SED, then I don't believe that that's a detection. It's a limit. I'll just turn it into a limit and go with that, because the true brightness of the source has got to be fainter than the noise at this location, because it's not immediately obvious in WISE3 and WISE4 that it's there. Does that make sense? The source is clearly there. It's really at the sky at this location. It's just not easily detected at 12 microns or at 22 microns. That's a limit. Does that make sense? So the takeaway point is that detections are a measure of brightness. Limits are a measure of the true brightness of the source must be fainter than this. And it's represented in plots as an arrow pointing down, meaning the true brightness of the source must be fainter than this. It is rare, but you can also go the other way. If you say the source is saturated in our data, we don't know how bright this thing really is, but it's brighter than the level at which our source saturates, in which case you have an arrow going. If it's a SED, then the true brightness is brighter than this level, so you have an arrow pointing up. But a limit in an SED will be an arrow pointing down, because whatever the true brightness of the source is, it's fainter than this, right? Make sense? Hopefully that makes sense. Here's a real life example, just momentarily jumping ahead. Here's a spectral energy distribution. We'll talk more about this in later chapters. There's a limit, right? It's an arrow pointing down, meaning that I don't know what the true brightness of this is at 22 microns, but it's got to be fainter than this because this is where the noise level of that data is at this location. The source is real. It's been detected at many, many bands. I believe it's detected at 12 microns, but I do not believe that it's detected at 22 microns. We don't know what flux this object has at 22 microns, but it's below where this arrow falls in this spectral energy distribution. Hopefully that makes sense.